Well, welcome everybody to our very first virtual stargazing program. I'm Samuel Singer, the founder and executive director of Wyoming Stargazing. We have a couple of our board members who are logged in right now, but I want to introduce Mike Adler, who is actually doing the stargazing for us at his observatory just outside of Jackson. He's got a pretty impressive setup there with a fully robotic telescope, which I think he's controlling from inside his house right now, not actually in the observatory. And we've got a bunch of cool objects we're going to show you tonight. And so what you're going to see on your screen are all the programs that Mike is using both to control his telescopes and to control the cameras that are attached to the telescopes. And so Mike will tell you a little bit about how that all works throughout the evening. And as we get to each object, we'll also share with you a little information about what you're looking at. And then we'll show you some pictures of what these objects can look like if you do lots of exposures and then stack them all together in color. What we're going to see tonight are just black and white images. But after you get these images and lots of different filters, you can stack them all together and create pretty impressive pictures like the ones Mike's taken before. And so with that, Mike, I'll kind of let you explain what you're doing, and we'll start looking at some objects.
Yeah, so so the screen that you're seeing here is the screen that's actually controlling the camera. And well, we didn't see much here. Let's see what's going on. Okay, I got it. Okay, yeah. So what we're seeing here is the screen that's actually controlling the camera, and I just have this big white this big fuzzball because it's not dark enough yet to make this work. But but maybe go back to the other one and talk a little bit while it gets a little darker. Okay, so I'm gonna let's see. I'm gonna go to a new screen and go to this window. So so this is the screen that's actually controlling the telescope where it's pointing. So there's a bunch of different programs here that that are required to do all of this. In fact, I can control. Let me just show you this thing. Let's see. Let's do this program. Let's see, this one. So this thing is a program that allows me to close or open my observatory. So I'm now opening it a little bit more by pushing a couple of buttons. And it's the observatory has got two louvers on it. It opens, it totally open. I can make it so it's totally open. So anyway, I just did that. So that's one of the things I have to do to start the evening out. Then usually what I have to do also is I look at this screen, which is this screen is controls the focus of the telescope, which I don't think I'll have to do tonight because I've been using it. So it's probably going to be well enough in focus without me messing with this. But this thing controls a lot of things on the telescope itself. So the focuser, I can rotate the object that I'm looking at. I won't get into why I need to do that, so I won't, but I can do that. Then there's also I can for a night when it's cold, I can heat the telescope a little bit so that the mirrors anyway, so that they don't condense and I don't get frost on them, or at least it tends to keep them away. So I do all of that with this program, and so I'll go back to the program that, so here's the telescope pointing right now at an object. So right up here is pointing at Messier 101, which is a galaxy. And it was, when I tried to take a picture of it a few minutes ago, but it was too, it's still not dark enough to do that. Let's try, so I'm going to point it at something else temporarily. Let's let's see if the Orion Orion is still available. So let's do, so that's Messier. So what I do is I type in the object, which is Messier 42, and then I hit find. And that's, so now you see that red dot is now telling me where Messier 42 is located. And if I hit this button, it's going to tell the telescope, it's going to ask me if I want to do this. And I say yes. And so now you'll notice the yellow dot up here is moving on the screen. And it's moving, it's moving over the pole. So it's just about, as soon as it gets to this position here, it's actually pointing at the North Star right now. And now it's coming down from pointing at the North Star, and it's lowering itself to come up to the Orion Constellation, which right now Orion is just about getting really low in the sky, but we might actually be able to see something here. So I'm going to take a picture once it gets there. And you'll see it's slowly coming down to it. So the telescope, one of the advantages of having a telescope with a permanently mounted, an observatory with a permanently mounted telescope, is that this telescope is already aligned. And so I don't, unlike when Samuel goes out and sets up his telescopes for a night of viewing, he has to align the telescopes. Well, since I'm not moving the telescope every day, it's on a permanent pier, it's aligned. Now, I have to tweak the alignment now and then, but for tonight's purposes, it'll be fine. And so now it is pointing at M42, and I'm going to go up to a different screen, the camera screen, go back to the camera screen again, and so here we are. So now I'm going to try to take a picture of this one. I'll give it a 10-second exposure, and we'll see what happens.
Mike, I was just thinking that maybe at some point this evening you can bring up a picture of your observatory so people can actually see. Okay,
well, yeah, I can do that. You know, I might have to go to my other computer, but I have another computer that I can also bring up on Zoom. So yeah, we're actually looking at M42 right now, and so you can see the bloom around it. It just says that the sky is not real dark, but that's it. Let's see if I can tweak this a little bit, make it darker. Yeah. Let's try a shorter exposure. Let's try 5 seconds or 3 seconds. This won't take very long because it only takes 3 seconds to take the picture. Oop, okay. Now I got it. Now let's take it again. Got some streaks here. Now, what's going on with those lines? Oh, it's too short an exposure again. Okay, let's go to 5 seconds. Well, we're getting some. I don't know why this is happening. Let's try go to 2 and 10 seconds. Seem to be happier at 10 seconds. Oh, I just changed. Well, I guess we'll have to deal with the. Okay, I have to ignore what's going. I'm not sure what's going on with these bright lines, but it's kind of, the image is kind of blown out, unfortunately. But this is the Orion. You can see this is the very brightest part of it, and I can dim it down. Okay, well that's better. All right, that's better. Okay, now that's looking a little nicer. Okay, so you can see it. This is the trapezium, where the brightest part of it is. If I dim it down and then zoom up here a little bit. Okay, now you actually, I can see the 4 stars. Dim it down some more. Okay. Okay, there's the trapezium. Well, that's not such a bad image now. So, so those are the 4 stars that you see in the trapezium, and this is the nebula that's around it, and this is it's called the dark horse. It's just a dark nebula that's sitting right here, and if I brighten it up a bit, you'll see a little more of the nebula come into view, and so you see it spreading out in this. There's a wing that comes off in this direction and another wing that goes off in that direction. I can make this a little bigger too. All right, well, that's not too bad. Do you want to say anything, Samuel, about that?
Yeah, so there are lots of different types of nebulae. We'll look at a couple different types tonight. This one is an emission nebula. Another way to talk about it is a stellar nursery. So we're actually seeing the birthplace of stars here. So some of the very youngest stars in the Milky Way galaxy are in these types of nebulae here. They're just several thousand years old, which is pretty young if you live to be several billion. Just kind of like a few minutes old in that respect.
Yeah, and this is a hard picture to do if you actually try to take a picture of the whole nebula, which goes way beyond the size of this. This is something, I don't know, I haven't looked at it recently, but I think you're seeing a little more detail than you would see with your naked eye. You would definitely see the 4 stars with your naked eye. You would see, I think you can see some of this, but I think we're seeing a little bit more into it than you would see with your naked eye. But bring it out. I'm going to take this picture again because it's getting darker as we speak, and so the picture will get better as the sky gets darker. I'll just redo it. Okay, now we'll adjust this. Yeah, I see it's a little better now. Still getting these. Okay, so now we're seeing this part of the nebula a little more clearly. You're seeing a little more up here, you're seeing this is all part of the nebula. It sweeps down this way. What was amazing is there are sketches of this that go back to the 1700s. So people didn't have cameras at that point, but they could see this, and they had telescopes. And there's some very accurate sketches of this that have been done in the 1700s, and it frankly doesn't look any different than it does now, which is amazing. So I can, yeah. So anyway, that's looking at the brightest part of it, and then as I come back on this cursor, we're seeing a little bit more of it. Oh, that's nice that we're able to see that. Let's see, what else is there? Well, this is the brightest thing. I could try to take a look at the horse head, which is close to here. That would be go. I'll just leave the screen open and I'll move it myself. I think it's IC 342.
So the Orion Nebula that we've just been looking at,
no, it isn't.
It's about 1,600 light years away. Each light year is about 6 trillion miles. So you can do the math. Many, many miles away, but it's one of the closer objects that we're actually going to see tonight. It's about 12 light years in diameter, this object. The solar system, more or less, maybe a light year in diameter if you take kind of the gravitational boundary of our solar system. So this is at least 12 times as large as the entire solar system, roughly 700 stars. in this object. So we're just seeing the several brightest ones.
Yeah, see, IC4, I think it's IC430. I think it's IC434. Okay, let's try to see, find it. It should, yes, very close by, so I guess that's right. I'm going to hit it, tell the telescope to go there, and we'll see what we can see here. Okay, so we're there. Now I'm going to get this out of the way and go back to my screen. And we could take one more picture of this because again, as we've been talking, it's now hour after sunset, and so normally I don't start taking pictures at least sort of an hour and a half after sunset, because the sky, you need an hour and a half to really get it to be dark enough. Oh, I see. I moved the telescope. Well, okay, so we can't take another picture of that, and we're not seeing anything very interesting here. Yeah, it's just a blank sky. Now let's try for 20 seconds.
I wanted to mention if anybody has any questions about either how the telescope works, the camera, or about the objects we're looking at, you can either unmute yourself and just ask them, or you can type your question into the chat window, which you can get to by bringing your mouse down to the bottom of your Zoom screen. You'll see a little chat option down there. So feel free to ask all the questions that you have about what we're looking at, and we'll do our best to answer them for you.
No, this is not working out. Okay, I'm going to go back to where we were earlier. Maybe point away from the. Let's see. Let's try. Messier 101, which is off away from the setting sun. Okay, actually, while I'm doing that, let me just do this. I'll let you all see this happening. Share. Am I sharing the screen now? I'm not sure what I'm sharing. Anyway, I think you're seeing the SkyX, which is what's controlling the telescope. And it's so this little red yellow dot is tracking, is telling you where the telescope is being pointed right now. All right, so it's there. So we're now going to go back to the camera. And we're going to take a picture of this too. I'm seeing absolutely nothing here. So what is it? I wonder if I'm. Ooh. Okay, that's already open. So, all right, let's try this again. Maybe 10 seconds. No. Let's see.
Mike, I just found a picture of your observatory and emailed it to you.
Okay, I can actually go and get I have my pictures on a hard drive, a portable hard drive, which I can go and plug into this computer, so I can show them on this computer. Why I'm not seeing that? I'm going to pick a star here, somewhere by. Maybe. What's the? Okay, I can check on something here. What's the elevation? No, it's up there. I should be able to see. We're seeing stars, so I don't know why I'm not seeing this. Let's pick something. Let's pick something on the other side. We picked M42. You have a suggestion of something sort of?
Yeah, maybe some stuff up at the zenith might be good.
Okay.
Either M51 or 81 or 82.
Oh yeah, well, let's try. Okay, let's try M81. M81. Oh, didn't get this. Yeah, there it is. Find. Yeah, there's M81. So let's go there.
So M81 is a galaxy, and so hopefully we'll see some nice structure to it here in a second.
Yeah.
A lot of the objects we're going to be looking at tonight have a certain catalog number M, letter M rather, in front of the number. M stands for Messier. He was a French astronomer who was a little obsessed with finding comets. So he was looking at all the fuzzy spots in the sky, hoping that they would move night to night with respect to the background stars. And most of the objects he looked at didn't turn out to be comets. They didn't move from night to night. But what he ended up doing was putting together one of the most accurate and detailed catalogs of all the fuzzy spots in the night sky. And so we know that group of objects today as the Messier catalog, and it has 110 of the brightest fuzzy objects that you can see, some naked eye and some with even small telescopes. So we're going to look at quite a few of those Messier objects tonight. The one we looked at earlier, the Orion Nebula, was M42. And now we're going to a pair of galaxies, Bode's Galaxy and the Cigar Galaxy, which are respectively M81 and M82.
Yeah, maybe something. I'm a little worried about what this my mount is doing right now. Yeah, something is fouled up here. Something is fouled up with the mount. It's. I'm going to tell you what. I'm going to go and get my. I'm going to shut down. Right, let's see. Let's shut the telescope, disconnect telescope. And I'm going to start up, connect telescope. And I'm going to ask it to find home. So I'll be right back.
So while Mike is checking on that, I'm going to reshare my screen with you. And I'm going to show you some, first a map of where all these objects are that we're looking at. So hopefully you can see my screen now. And so earlier we were looking at the Orion Nebula, which is way down at the western horizon right now, just below Orion's belt. So you can see M42 down here.
Hey, Sam. I'm sorry, we can't see your screen yet.
Oh, you can't? Interesting. Thanks, Ethan. Appreciate you letting me know. Some people can see it, I think.
I can see it.
You can see it?
Yes.
Oh, okay. So we were looking way down at the horizon, so I suggested to Mike that we'd look at some objects up near the zenith at the very top of the sky. And so we were just trying to look at M81 and M82, this pair of galaxies just off the Big Dipper, which is pretty high up in the sky right now. So I thought that might make it a little bit easier for the telescope to find. Did you find anything out, Mike?
Well, I got my hard drive. I just want to get the hard drive, which has all my pictures on it and the observatory. So I can now easily on this computer show some pictures too. But
Gotcha.
I just restarted the mount, and so I'm now going back to M81 after restarting the mount. So okay, so now let's take a picture now this time and see what happens.
So I shared my screen for a moment, so you should be able to override me just by sharing your screen again.
Okay, I'm just going to see if what I get here. I'm taking a picture right now.
Yeah, sounds good.
Hey Sam, if you don't see it, Ethan made a comment. If you go to the top of your screen and hit View Options, you can choose which screen you can see, whether it's Mike or yours.
Okay, there it is. All right. Do you see my screen?
Yes.
Okay. Yeah, we're looking at M81 right now. Okay, so the only good news is this, it's a little fuzzy. I can try to take a longer exposure, but you can see some of the, you see right here, this is the center of it. I can dim it down a little bit so I can see the, well, okay. The most interesting, okay, so you can just see the arms here. Now, this galaxy, through a telescope with your naked eye, the very most you could ever see here is a fuzzy blob. This at least allows you to see some structure. Now, given that we're seeing something, I'm going to increase the exposure to 20 seconds. That's not too long, and we'll see. We'll see a little more detail. I can show you. I can also show you what this looks like in a picture. But the fact is that with your naked eye, unfortunately, none of these galaxies can you. The one you can see that even with your naked eye is the Andromeda, but it just looks like a little fuzzy little hazy spot in the sky. But so now you're seeing, you can see these arms, and so these are the two of the arms. So maybe what we'll do is we'll look at a bunch of objects, or we could even take a little break and I could show you what this looks like as a picture. So yeah, that's we could try M82, which is right next door, and that's close. So why don't I do that and see what happens?
Yeah, let's go for it.
Yeah.
So both these galaxies are about 12 million light years away. So quite a jump from the Orion Nebula, which was just about 1,200 light years away. So we're well outside the Milky Way galaxy now. And still just looking at some of the closest galaxies to us. Mike mentioned Andromeda. That's the closest galaxy at just under 3 million light years. So these ones are 4 times farther away at 12 million light years. And these two galaxies, Bode's galaxy and the Cigar galaxy that Mike's got up right now, they actually interact with each other. And he can tell you a little bit about that.
Yeah, this one, yeah, I can, so you're actually seeing a fair amount of detail on this one. You see, so here, these are the outer areas of it. And the center part of it, the picture of when you get a picture of it, it's bright red. And what's going on is this galaxy is M81, and as a result of that, it's creating a tremendous number of stars, and those and the light from the hydrogen gas is being excited by the stars, and it just turns out to be a bright red in an image. But yeah, that's actually pretty good. That's we're seeing more detail here than we were seeing in the larger one. So that's kind of cool. Let me just go to. It's unavailable.
So the light we're looking at here is the accumulated light of several hundred billion stars. These galaxies are probably a little bit smaller than the Milky Way galaxy, but still at least a couple hundred billion stars in this one and the last one we looked at.
Now let me go to some pictures here, and I'll show you what this looks like. The two things that we just looked at, what they look like if you expose them long enough. Astronomy pictures, ELSI pictures. I can also show you what my observatory looks like. Let's go down here. M81 Messier. There we go. All right. Okay. Actually, let me show you this one first. I'm going to have to change my sharing here. Okay, this is. This program is really slow. I have to. Irritating. It takes forever for a simple picture program to actually show a picture. Okay, here it comes. It won't take this long to show. Once I show this one, okay, there it is. So there's the two of them. So the first one you were looking at is M81 over here, and this is M82. This is captured in a single. This is captured with my 6-inch telescope, which actually can get. Actually, it isn't. I took two pictures with my 20-inch telescope, and I pieced them together. But we were just looking at this one. Now, what you couldn't see in that image I showed you was these parts out here. And this was the red flare. This is the hydrogen gas emitting red light from being excited by the stars that are in the same area. And this red gas, this hydrogen gas, is being stolen from this galaxy over here. And it's and in fact, what was it? What was the question that I was being asked, which was what was causing the? Well, anyway, enough of that. So that's pretty cool. So you were seeing this some of the detail here. Now I can go and let me just minimize that picture and look at this. So this is a more detailed picture of that one. So you were seeing some of the structure, and we can go back to that because it's still in the. I still have it. You were seeing some of this right in this area. And this is M81.
We can't see that screen, Mike.
Oh, yes, I have to. Oh, yeah. Okay, I'm screwing up. Can't see that screen. All right, so we got to go to resume share. Okay, I see that. We were seeing that previous picture. So I have to. Okay. I got to share. I guess I have to share screen again. All right. Okay, there it is. So that's a detailed picture of M81. And what we were seeing was these two bright arms, this one and this one. All right. While I have these up, let's see. Well, let's go back since we did look at we just were looking at M42. We can go back and find M42. M8, 40, and 42. Okay. Yeah.
So we're going to go back and look at the Orion Nebula. Now that it's a little bit darker, we should be able to see a bit more.
Yeah, we can go back and actually look at it again, but it's sinking fast as well. So I've got to see. I've got to do the sharing thing again. Where is it? I should share screen. So this is what the M42 is. This was taken with my 6-inch telescope. What we were looking at before was this area right here. And if I blow it up, if I zoom. We were looking at this. Remember I showed you that dark area there? That was that dark area. Here are the 4 trapezium stars, and we were looking at this part here. Okay, so let's go back to the picture. We were just, the actual telescope picture, which was here, and I have to then change the sharing again.
You should just be able to, there you go, and just toggle to a different screen.
Well, that's what I'm doing. But what I have to do is I have to do a new share. I have to point up there, then I toggle to a different screen.
Gotcha.
So this is the screen we want to toggle to. So I have to hit share. So okay, so that was the image we were just looking at. I could try, since we were very close to it, let me go back to M81 and try another picture of M81. Because it's so close, it won't take the telescope but a second to get there. And we'll just do find. And now we'll take, we'll go there. And now we'll take a 20-second picture. Maybe we'll take a, I'll splurge and we'll take a 30-second picture of that.
Just wanted to make sure the folks knew who are just joining us. If you have any questions, you can type them into the chat window at the bottom of your screen, and we can answer those as best we can.
Second exposure. All right. So let's see. Well, we're not seeing an awful lot more than we were before. We're seeing a little bit more. Yeah, we are seeing more now. You can see an arm over here and some more detail in this area that we weren't seeing before, and you can see some of the structure in here. Okay, maybe that might be a better picture to look at. So should we go back? You want to try M42 again? And
I mean, it's going to be pretty close to the horizon.
so try something else. We can try.
M51 is pretty close by.
Yeah, it'll have to flop. The telescope is an equatorial telescope, and it has to it either points on one side of the vertical or the other side. M81 is on one side, M101 is on the other side, but we should be able to, the other night I was able to see M101 has a lot of spiral arms, and so there it is. And now I'm going to tell the telescope to go, and there it is, zooming over.
We're still looking at the camera screen.
Okay, yeah, well, I'm watching it, so I won't bother. You've all, I think most of you have been seeing the telescope moving, so it's not that exciting. Okay, we're going to go back to the camera. I forgot to. Oh, all right, here it comes. Yeah. I may be having problems with the telescope flopping over to the other side, so this is looking a little, this may not work. We may have to stay on the western side.
Okay, there's plenty of good stuff.
Well, we'll see.
There.
It's approaching it, so I'll give it a shot and see what happens. Normally it doesn't move this slowly, which is telling me that maybe something is fouled up here.
While it's moving over there, do you want to pull up a picture M51?
Okay, it's there now. So
okay,
let me just take a picture and see what happens. If not, I'll have to restart the telescope. All right, so here we are. Camera control, start. Now, I probably shouldn't have taken a 30-second exposure, but that's where it was set up the last time. So we'll see, hopefully we'll see something. Maybe I have a cable. Yeah, well, no, there's no cables in the way. Oh, this works. Okay, there it is. All right,
Yeah.
it's working. It just took a while to get there. Okay, so there it is. So now you're seeing, I can brighten this up some.
There
Yeah,
you
so
go. That's
getting,
nice.
we're getting a nice image of M101. That's cool. All right. Yeah, so this is also one that is not exactly next door. This one is like 22 million light years away. So this is even further away than M81 is. This is still considered very close to us by the standards of our universe. But yeah, it's. But you can see how many how many arms there are here, and all these little bright spots that you see in the image are places, if this was in color, in fact, I'll show you the picture of what this looks like in a second. These are bright red areas, like down here. These are areas where there's a lot of hydrogen gas and where stars are being formed.
So just like the Orion Nebula, right?
Just like the Orion Nebula, but this is in another galaxy totally. So yeah, so we're not seeing the details, but we are seeing a whole area of gas in. So we're seeing a nebula, as Samuel was just saying. We're seeing a nebula. We're seeing the sign of nebulas in this other galaxy, which is 22 million light years away. So that's pretty cool. In fact, we'll just leave that there, and I will go and show you what a picture of it looks like. And I know I'll have to change screens, and so that's M101. Okay, here's a picture of M101. Let's use this one. Okay, so I'm gonna, actually we're seeing it flipped around, so let me, well, it's okay. Just go up here, share, right here, share. So here's a picture of M101 that we were just looking at. If I, let's see, I think I can flip this one around. No, should be able to, I want to rotate it. It's upside down from the image we were seeing. If you remember, there were a couple of long arms here, but here you can see, I won't bother. Here you can see all these red areas. And if you look closely, you see little bands of red, but these, we were looking at this bright area right here in the picture just a bit ago. And that's an area of just lots of nebula and star formation. You'll see this little zig here, that little spot. That's actually another galaxy. That's a ton distance further away. So that's another galaxy in the same field of view as this one, probably maybe 500 million light years further away or something, ridiculous amount. And just so you know what a light year means, when I say that this is 22 million light years away, that's okay. So that's a distance. But what's also significant about that is that the light it took to look at that image we are looking at on the telescope camera, it took 22 million years for the light to reach the telescope. So we are seeing that galaxy like it looked 22 million years ago. So that's kind of amazing when you think about it.
Yeah, it really is. Yeah. Galaxies change pretty slowly, but in 22 million years, probably a few things have happened.
Probably is, yeah. And even, some of the closer ones, Hubble has taken pictures of the Eagle Nebula, the pillars of creation over a 15-year period. And they've actually seen differences, But of course, that is also about 1,000 light years away. So what we are seeing is what it looked like 1,000 light years away, and then 1,000 light years minus 15 years. So it was 15 years different, but it was 15 years 1,000 years ago.
Right.
So it's
And
kind of mind-boggling.
I think on average you get about one exploding star per galaxy every 50 years. So in 22 million years, there have been a lot of stars that have exploded in this galaxy.
Yeah. So yeah. So going back to. So we go back to the actual. Let me switch the screens again, and we'll look at the picture that we just took. So there's the picture that's what we were just looking at a few minutes ago. And you can see, remember, actually probably what we were just, I guess the orientation was the same. We were just looking in detail at this area up here. So that's pretty cool, yeah.
Mike, I was thinking we might do 2 more galaxies.
Okay.
Maybe one more face-on, M51.
M51. That's a dimmer one, but we should be able to see something. So it's close. It's not too far away from this one. So it won't take the telescope too long to get to it. Okay, I'm going to change the view so you'll actually see what's going on here.
Cool.
Okay, so now you're looking at the SkyX program, and here's where the telescope is pointing, right at M101. Now what I'm going to do is enter the name for M51, which is one of the really iconic galaxies in the sky. And I'll ask, see, so it's right next door. So that red circle is where it is relative. And so now I just hit this little button here, and I say, do you want to go there? And I say yes. And so now these 2 galaxies. This is the time of year to see these 2 galaxies in the spring. This is the best time for these 2. So now I'm going to go back to the camera, and okay. So I think I'll take another 30-second exposure of this one, and so we'll just click away. So now what you're seeing is this is the controls screen for my camera, and this down here tells it this camera takes black and white pictures. And you ask, how do you get a color picture out of a black and white camera? And the answer is that there are color filters associated with this. So there's a filter wheel that is in front of the camera. And the filter, there it is. Wow.
Yeah, there you go.
Wow, that's pretty cool.
It's a crowd pleaser, right?
Yeah, right there. That's amazing. Okay. Well, what I was saying is, I'll just finish my little spiel here about this thing. And this is, we were looking at the luminance filter, but I have 7 filters. I have a red, green, and blue filter. So when I make that color picture, I actually have to take pictures through each of these different filters separately and assemble them. And so this is, this is really beautiful. And I can, part of what's happening is, wrong way. Part of what's happening is it's getting a little darker. And the sky, it's a nice night. And so we're getting some nice clear views of this. That's 100%. I could even, okay, let's stay with 100%. That was better. So anyway, there you go. And what's interesting about this guy is, I can change. There's actually 2 galaxies here. This is another galaxy, and it's gravitationally bound to this galaxy. And it's actually circling around it. And another interesting feature of this is that if you'll notice that this galaxy is, well, you have to sort of turn your head, but it's not perfectly round. It's stretched in this direction somewhat. And it's the gravitational pull of this galaxy that's stretching this guy out in this direction. And you'll see the same, I'll show you, we'll go to a picture of this shortly, but you'll see that these little spots here, they're actually all bright red spots where hydrogen gas is concentrated in a nebula, and that nebula is forming stars in this galaxy.
This galaxy is just a little bit farther away than the last one. I think this one's about 25 million light years away.
That's right, yeah. It's, yeah, it's in the same part of the sky, as you can see. I think it's in the same galaxy group.
Mhm.
Yeah, and what's interesting about these galaxies, you know, back 100 years ago, people thought all of these things were part of our Milky Way, our galaxy. They thought these were nebulas in our galaxy. And it wasn't until Hubble and with the strong help of a woman, and why do I keep on forgetting?
Henrietta Swan Leavitt.
Yeah, Leavitt, right, at Harvard, figured out that there were these things called Cepheid variable stars, and the Cepheid stars have a frequency associated that the frequency of variability is proportional to their brightness, and she figured that out. And so so by measuring the actual frequency, you know the true brightness of the Cepheid. And if you know the true brightness of a Cepheid, and you look at its apparent brightness in the sky through a telescope, you can figure out how far it is, because light brightness falls off as the square of the distance. And so Hubble was able to use Henrietta Leavitt's calibration. It's called a standard candle, because up until then, no one could measure distances in the sky. Something very close you could measure by parallax, that is, by when the Earth is on the other side of the sun in the summer and the winter, close-up things shift, and so you can measure its, you can infer its distance by that means. But things this far away there's no parallax. And so the only way you figure these things out is through some kind of device like Cepheid variable stars. It turns out nowadays there are other standard candles, like certain types of supernova called the type 1A supernova produces pretty much the same brightness, no matter how far away they are. So again, it's a standard candle. But anyway, Hubble was able to figure out that these things were definitely not part of our Milky Way. And for the first time, he measured the size of our Milky Way, but this is 20 million, 25 million light years away, way further away. Our Milky Way is only 100,000 light years in size. So, this is a real beauty, and this is one of the. If you're an astrophotographer, this is something that you've got to take a picture of. This is really important stuff. We can take a quick look at that picture too. Let's see. Go to photos here, and get rid of one of these photos. And I know you're not seeing this, so as soon as I get to it, I'll bring the screen up.
Sounds good.
Okay, pictures. Okay, that's M51. Here it is. So here's my picture of M51. I'm going to open it with a different viewer, which has a black background. No, I don't have that viewer on this. Okay, I have no choice. All right. So there it is. You're not seeing it. I'll get it to you in a second. So there it is. So there's my picture. This picture, it's interesting. You just saw it with your naked, in the, a 20-second picture. This picture took 60 hours for me to make. So, and the reason it took 60 hours is that I wanted to get the detail in it. And so you see, I can zoom in, and you can see a tremendous detail in these arms. And these are the areas we are looking at. The little bright areas were these things right here. These bright areas were what we were just looking at. And you couldn't see, and you couldn't see the color, of course, but all this red area is emission. This is a true color picture. And so the red areas are hydrogen gas, and the bluish color is just light scattered off of dust. So here you can see the detail in this other galaxy. It has its own name to it, by the way, but I don't remember what it is anyway. So anyway, it's another galaxy. Yeah, it's up there.
Galactic cannibalism there.
Yeah, and yes, and it's destined to be gobbled up by this guy. Yeah, it's not. And just so you know, the Milky Way is one of about 30 some galaxies in our what they call our local group. Our local group are all gravitationally bound, and in fact, see, the galaxy like this one is moving away. Everything other than in our local group, galaxies are moving away from us. Hubble figured this out. But in our local group, gravity is actually pulling these things together. Eventually, all of this in probably 100 or 50 billion years, all of these galaxies in our local group will be in one super galaxy. The first one is going to be the Andromeda, and it's in fact I don't think the Andromeda isn't up right now.
No, it's not.
But we can't see it. So, I can, that's the Andromeda. The Andromeda was the first. It was the reason I wanted to do this was to take a picture of the Andromeda.
Oh, nice. I didn't know that.
Yeah, this is really what got me into this whole thing. Was the Andromeda Galaxy. I saw some beautiful pictures of the Andromeda Galaxy, and I said, I want to be able to take a picture of the Andromeda Galaxy. And so that's what got me into this this whole incredible scene here. So I got to do a share again. So here it is. So this is the Andromeda Galaxy, and this is our nearest neighbor galaxy, and it's spectacularly beautiful. You can see it in the fall and the early winter. And but we are this is the only galaxy you can see any sign of with your naked eye. It is not very interesting through a regular telescope through your eye. You won't see any of these bands, but in about a 20-second exposure like we were just doing, you'll actually see some of this detail. And this one we're going to merge with in about 4 billion years from now. The Milky Way and the Andromeda are going to collide.
And we'll become the Milkomeda Galaxy.
Yeah, exactly. Okay, so enough of that. We go back to the. You want to move on to something else then?
I thought we'd end with one more galaxy and then go on to some different types of objects. I was thinking 104.
Okay, yeah, well, that'll be interesting.
Yeah, nice contrast with the Whirlpool Galaxy.
Okay, so so we'll go to M104 and find, and it's also very close. I hadn't remembered that. Oh, it's beyond the slew limit.
Okay, maybe not.
I guess we're not going to look at M104.
Yeah.
That's a little
too low, I guess.
Yeah, so let's see what else. We're up there. See, this thing tells me where we are. We're at an altitude of 55 degrees looking up in the sky. I don't understand why.
I think it's rising, so we maybe come back to it later tonight.
Oh, I see where it is. It's way down there. Yeah, it's way down here. Yeah, okay.
We'll let it get a little bit higher.
Yeah, okay. So we have to do something else.
I was thinking maybe some globular clusters.
Okay.
We've got M3, M92, that I think should be far enough over the horizon.
M92, and find it. Okay, so it's also on this side. So we'll see if we, it will be in the east. So further east than we are. Okay, the telescope says we can go there, so.
So we're going to an object back inside the Milky Way galaxy now, but not in the disk of the galaxy where most of the stars are. These globular clusters hang out in the halos of big spiral galaxies and elliptical galaxies too. And we think that's because they were separate objects that got captured gravitationally by big spiral galaxies. And so the stars in these globular clusters are really old. they actually predate the big spiral galaxies that they're found in. So some of these stars are 11, 12 billion years old, whereas the Milky Way is probably only 8 or 9 billion years old.
Okay, well, before I lose it, here's just another look at M51, the picture we just took a few minutes ago. All right, so now we're going to, I don't think I'm going to need quite such a long exposure.
I don't think so.
So I'm gonna go for I'll just go for 5 seconds and see what happens. Okay, there it is. Yeah, so this is let me zoom in a little bit. Yeah, we're you know, this is so bright. I can unbin this and shoot it at a bidding of 2, so we'll get a little more resolution, and I'll increase the time. So let's just take this picture. There's a feature in this in these cameras where I can it's called binning, and okay, where is it? Yep, there it is. Unzoom it. All right, that's a little better. Yeah, I can make the pixel. This camera is about 4,000 by 4,000 pixels. But if I want to increase the brightness of the object, like we're particularly for something like this, where we're looking at it at relatively low resolution, I can put 4 pixels together and call it a super pixel, and that's what I've been doing. But I'm because this thing is smaller, I binned it only 2 pixels on the side, so it's 4 pixels. We were looking at 16 pixels together to make one. Now it's only 4. But here you see it. So this is a globular cluster, and yeah, this is a. So this I don't remember how many stars this guy has, but a globular is probably has 100 to 1,000 to millions of stars in it.
I think this one's about 300,000.
Yeah. Okay. And it's a lot. And what happens in a cluster of stars? All stars were formed most likely in some kind of a cluster. The sun was in an open cluster, and over the eons, our sun is about 4 billion years old. Over that 4 billion years, it has somehow split off from its other sisters and brothers. But these globulars stay together, and one of the interesting issues about being in about Earth, and it's like the Goldilocks Paradox is why there's life on the Earth, is we wouldn't, if our sun was one of these stars in a globular like this with 100,000 other stars, we would not, we probably couldn't have survived. Life wouldn't happen because there's just too much interaction. The stars are just too close to each other, and just too much chaos for a solar system to form and not be disrupted. So it's probably, we were almost certainly born in our sun in an open cluster, unlike this one. And these are very old. All these stars are go back almost to the age of the universe. They're probably on the order of tens of 10 billion years old.
And packed really tightly together.
Yes. Yeah.
So you think about like the average distance of stars near the sun. The distances are much greater in our neck of the woods compared to inside a globular cluster.
And so what's cool about doing it this way, it's not quite the same as looking at it with your own eye, but we're able to see a lot more things this way because everybody can see it at the same time. So that's what's cool. And you would have never seen those galaxies, unfortunately, just by looking at it. You'd have seen something, but you wouldn't have seen the detail.
Yeah, even in a big telescope like we have with a 25-inch mirror, you can just barely make out the spiral arms. So there's one other globular cluster up in the sky that's even brighter than this one, M13. It's the the Hercules globular cluster, which is the brightest globular cluster in the sky.
Yeah, this is amazing cluster. It's called the Great Hercules Cluster because it's so famous. M13. I'm going to just do this and then I'll find it. Oh yeah, it's right next door. That's nice. Yeah, Samuel has figured this out, so that's great. Nice picking objects that are close to each other. That way the telescope doesn't have to work so much. All right. Okay, so here we are. Okay, so we'll do another. I'll do that. I'm gonna bin this one. Well, no, 2 is a bin. I'll bin this on 2, and we'll do another 10-second exposure. Wow, how's that?
That's nice.
Yeah, that's yeah. I think there are 1 million stars in this one.
Yeah,
and
we don't really know, but some of the
really
estimates are that high. Yeah.
See, I'm dimming but you see now you're seeing the detail in the center part of it. I can zoom in some more, but you can see the center part of this, and there's some interesting patterns here too. There's this X pattern, you see it here, X here, and a bar here. I actually have a picture of this one I can show. And we'll just leave that up, and I can go to that's M13. Let's see. I see M13. Here it is. Let's see. M13. This one. All right. Okay, now I'm going to just do this. Oh, darn him. Okay, so here's a picture of M13. And so you can see there is actually some color in this picture. Let me zoom in a bit. But you can see the yellowish stars. So these are and you can see all the smaller, whiter stars. And this X pattern, actually, we are seeing it more clearly than even in this picture. And the X pattern, I see it. It's right there and there, but it's not quite. It was actually more distinct in the picture we just took. Yeah, these yellowish stars are probably younger stars than the pure white ones. So anyway,
So this one's only about 25,000 light years away. So in the upper halo of the Milky Way. So about as far away as you can get and still be in the Milky Way galaxy. But a lot.
Yeah, the halo is this area right above the center of it, above and below, as opposed to in the arms. Yeah, and yeah, these are some of the oldest stars in the universe in these globulars. Yeah, so we can go back and take a look at compare the pictures. So that's what we were looking at. Not quite as nice as that, but let me unzoom it. So, all right, there you go. This is a nice thing. The globulars are nice visually. So that's one. The galaxies don't show up so well visually, but the globulars are really fun to look at with your eye.
Yeah, the view we get through our 25-inch telescope isn't that dissimilar from what we're seeing right now.
Yeah.
So there are a couple other open star clusters that I thought might be fun to look at.
Okay.
I was thinking of the Perseus double cluster.
Oh yeah. Okay. So let me go back to my where are we? Here we are. Okay. And what number is that?
It's an NGC.
NGC.
869 and 884.
Okay, I think we only need one of them.
Yeah.
869. All right. Okay, there it is.
NGC is the new general catalog.
Yeah. Okay, so now we just find and then okay, so that's back on the other side. So we're gonna take a trip to the dark side again. The telescope is going to go around the corner. So for it to point to something on the east side, it has to flip around. Now this is looking very far north and east at the moment. It's up near Cassiopeia, actually. Is that, in fact, in the Cassiopeia?
It's just between Cassiopeia and Perseus.
Yeah, okay, right. Okay, so we're there, and so now we'll come back. This again will be fairly bright, so I'm going to I'll just do a 10-second exposure and see what happens. Yeah, now this telescope has a fairly narrow field of view. Whether we'll see both of these together or not is another.
I think we'll just get one of them.
Yeah, there it is. Okay, we'll just get one of them, and that's it. So that's the difference between an open cluster and a one of these globulars.
Yeah, much more sparsely populated group of stars. But this one's really nice through a big telescope. It fills the field of view.
Yeah, yeah, you can see the. Let's see, I can let me zoom in. So there's looking at the whole thing. And yeah, the other one is not in the field of view. Yeah, the other one's not in the field of view. I don't have a picture of this one.
The other couple open clusters that I thought might be worth looking at were M44 and M67.
Yeah, M44. Okay, yeah, M44. M41 is Sirius. That will be gone, I think, probably
Yeah.
by now. Yeah, yeah. Okay, wrong. Okay, let me. All right, so let's go back. Let me go back to the screen here.
So these clusters are more along the lines of the groups of stars that our sun probably formed in and then drifted apart from.
Yeah, yeah. The sun. I think I used to know this. I think it takes. I'm trying to remember how many years it takes to go around the Milky Way. But our sun has made a couple of trips around the Milky Way in its lifetime. I think it's 250 million years or something like that.
Yeah, I think so.
And so it's been 4 billion years, so it's been around a while. It's made a couple of spins around the Milky Way. And in the process of doing that, it got split off from from where it was born. Okay, so. Okay, this is on the same side, but it's a little ways away. I can show you. You can see the telescope tracking. It's going right by, well, yeah. Actually, we're in the western side. We're on the western side right now,
Yep.
looking west. Orion is down here in the mud. Okay, we're there. Okay. No, we're not seeing an awful lot here. I don't know if I don't know if I'm missing it or it's. Could it be this sparse?
Yeah, it could be.
Yeah,
It
yeah.
looks great through a pair of binoculars.
Okay, yeah, it's too. This telescope is too much focal length for this this object.
Yeah,
Right.
the field of view is just too small.
Yeah, yeah. Okay.
Yeah, I was kind of curious what it was going to look like.
Yeah. Okay. Yeah, it's pretty sparse. We could take a look. Let's see if let's see. Go back here.
You were going to suggest that we try to do 104 again?
Yeah, I could just see if I could. If 104 is visible now, or the
Yeah.
telescope will point to it. Find. Let's see.
Yeah, it may still be too low.
Oh, there it is. Okay, so let's see if I can get there. Well, we'll see.
All right, cool.
It might be. It looks like it's going to go there.
Yeah. So this is going to be another galaxy, the most distant galaxy we've seen so far. This one's called the Sombrero Galaxy. So it's a beautiful edge-on spiral galaxy in contrast to the face-on spiral galaxies that we've seen before. So we're not going to see lots of spiral arms. We're just going to see this more kind of like broad line with a little bell shape at the top.
This is
the Sombrero
actually
name.
right, and this is actually below our below the equator. So this is actually in the southern. So this is quite low in the sky. Let me just see how high we are in the sky here. The telescope tells me what the altitude is. Well, no, we're not too bad. We're 27 degrees up, so it's not, you know, it's not way down.
Yeah, it's really just in the springtime that we get a good view of this object.
Yeah, yeah. So go back up here, and, go back to the camera view, and now I'm going to. The program is taking us. Is spinning its wheels here a bit. All right. Okay, so we're gonna. Oh no, it's still spinning its wheels.
Thinking about something, huh?
Yeah, it's thinking. The computer is thinking about something.
So this galaxy is it's about 30-some million light years away, 31 million.
Yeah, this is I can show while we're letting this computer. Let's see, it's M104. I have a picture of this one too. There it is. That's what it looks like.
And how many hours of exposure time is that one, Mike?
That's quite a few. It's not as many as the M51, which is, by the way, is called the Whirlpool Galaxy. I did 51 on that one because I did a lot of sharpening to bring out all the details. So I needed a really low noise signal, which means lots and lots of detail. You can see there's, even in this picture, there's not an awful lot of detail in this picture. Okay, so let's see if this program is not happy. I may have to shut this program down and restart it.
The camera program?
The camera program. Yeah, camera. So I'm going to, I may actually, these things happen, unfortunately.
Yeah, so the shape of this galaxy is not dissimilar from the other ones we've looked at so far. It's just rotated at 90 degrees from our perspective. So we're just seeing it as edge on as opposed to face on. But it's a gorgeous spiral galaxy. What differentiates this one a little bit is it has a lot of dust in the outer reaches of this galaxy, which is not always what we see.
Get rid of some of this. I got to find the program again. It's buried underneath the.
Okay.
What is it? Yeah. Get rid of this guy too. Oh, here it is. All right. Okay, here we are. You can't see anything yet, but I have to start the program up, which means I have to connect to the cameras. And there's two cameras that this is controlling. It's the one camera we're not using, even though it's there. Okay, so in theory, I'm connected. So all I have to do is actually take a picture now. Okay, let me put this thing back to resume share. Okay, we'll go to new share, go back to the camera. Okay, so the other camera is a little tiny camera. When I'm actually taking pictures, the telescope is tracking. You'll notice that when we are looking at it, the objects aren't being blurred. The telescope is tracking the motion of the Earth in a sort of what I call open loop. But if you really want to take a detailed picture of 20 minutes or so, even 10 minutes, it's not good enough. So there's another camera that locks onto a star in its field of view, and that's what this other camera, and it provides a correction signal to the mount to keep that star so that it doesn't move in the field of view. So that's why you can get pictures that's taken out, taking a long, long time without blurriness. Okay, so here we're going to try this picture, and let's see. I got to go to single, and I think we're all set here. So. Okay, we're clicking away.
So far, all the galaxies we've seen are all spiral galaxies. There's a whole another class of galaxies called elliptical galaxies. They're a lot less pretty to look at. They're just these big blobs of stars. And I don't know if there are actually any good ellipticals up right now to look at.
Yeah, I must admit I don't tend to look at them myself because for that very reason.
Now, I know the Virgo cluster has some big ones, but I don't think that's visible this time of year.
Well, there it is. So
yeah, there we go.
Success. All right. So we'll zoom in here a bit. No, that's not too bad.
No, it's nice.
That's cool. Yeah. So that provides a real contrast. You were seeing, the M82 was sort of edge on too.
Yeah.
That was edge on too. But this one shows, Samuel was talking about the halo where those globular clusters are. That's what this is. This is the halo that's in the middle of one of these galaxies. So this probably is what the Milky Way looks like edge on. Well, that's pretty cool.
Yeah.
All right. I'm actually impressed that we're getting, this is a pretty good night because we're getting fairly decent pictures here.
Yeah, it's a good one.
Yeah.
Mike, do you want to try for the comet?
No, you know, I don't know where the comet is.
I've got.
The comet blew up, by the way.
Yeah, I know. I just saw the reports on that yesterday. We should still be able to see something. I've got the right ascension and declination.
Well, you can give it to me and we can try.
Okay.
We you know, I can do it that way. So if you've got it, you know, the problem is this telescope focuses in such a narrow. If it's not right there, if it's moved from that, you know, we aren't going to see it. But
yeah, it's basically like trying to find a needle in a haystack.
Yeah, I was able to find the comet Lovejoy about 5 years ago, and I have a nice picture of that.
Yeah, I remember seeing it.
Yeah, so
I just figured,
okay.
like, you know, in the interest of highlighting, you know, what Charles Messier was trying to do for all his life.
Okay.
We've been looking at all the objects that weren't comets.
Okay. Okay. So tell me what it is now.
Do you want right ascension or declination first?
Right ascension.
Okay, it's 6 hours.
Okay, 06.
12 minutes.
1, 2.
And 26.1 seconds.
I think 26 is going to be good enough.
Okay.
All right. Okay. Okay. Declination.
65.
65.
Degrees, yeah. 8 minutes.
08.
And then 8.1 seconds.
8.1. All right, this looks cool. So now I'm going to hit, actually, if you want to see what I'm doing, let me just put, I'll show you what's going on here. Okay, so we're looking at my screen here. So what I just did, Samuel just read off these. And so there's a navigational screen. I just entered in those numbers. Now I'm going to tell the telescope to slew to this particular spot. And
this is when everyone needs to cross their fingers.
Yeah.
And toes.
I don't give this a lot of hope, but we'll see. Okay, so you can see the telescope moving. I don't. Yeah, it's going to the.
It's going to the right part of the sky. It's
yeah,
good.
well, that part is good. Yeah. Yeah. Okay. Okay, it's way up north. It's way up in the northern part of the sky.
Yeah, it's right by Ursa Major.
Yeah. So here's the pole right here, and so it's.
What is it doing now?
Well, it's just moving slowly. So there's Perseus. Okay, it's tracking now. So we're there.
Okay.
Okay. So now I'll go back to camera view and all right. Okay, so that's one more view of M104. And I'm going to click it out. Save changes now. Well, you know, I could save. I haven't been saving these. Maybe I should have. All right. Okay.
Hopefully they're all still stored in the buffer somewhere.
Yeah, probably. Okay, so here we are. So now we're going to do I don't know what exposure. I'll just do something less than 30.
Yeah, it shouldn't be very much.
No, I'll just.
I think it says it's the magnitude of it right now. The 8th or 9th.
Okay. Yeah, it's getting close. In theory, it's getting closer. The fact that it blew up, though, probably means it won't be the spectacular.
I don't think so.
Yeah. Okay. Well, let's see what we get.
Oh, we got it.
There it is.
Ha ha!
There it is. Okay, let's do a little longer exposure on it. Now that we know it's there, I'm going to go to 20 seconds. And in fact, I'll, given that we're seeing it's small, I'm going to reduce the binning, and I'll go to 30-second exposure now, binning of 2, so we can zoom in on it. Amazing.
Yeah, we might actually be able to see the separate fragments.
Okay. Well, that's cool. I
Yeah.
never thought. It's actually pretty small, so but this telescope is actually sort of the with Lovejoy. I use my 6-inch telescope. All right. All right. So let's just zoom in here and move this out of the way. Okay, there it is.
Yeah.
Yeah, I can let me just go to 50%. Yeah, amazing. Well, there it is.
Yeah, so that's Comet Atlas. There were some people who were really hopeful this was going to be a super bright naked eye comet sometime in May. But as Mike was saying earlier, it just disintegrated a couple days ago, as a lot of comets do. So it's probably not going to become naked eye visible, but we can still see it in the big telescope.
Yeah, it was. Getting closer to the sun, which means the sun's gravitational force was just too much for it and ripped it apart.
Yeah. So comets are they're pretty small objects. Some of them, are only, like a mile across compared to the stuff we've been looking at already tonight. So basically, a dirty snowball, big chunks of rock covered by lots of ice, frozen gases that's left over from the early formation of the solar system. And occasionally these things get kicked in towards the inner solar system. And when they do that, they get close to the sun, the frozen gases and dusts vaporize, and they grow these really long tails. And that's actually what we're looking at here is the tail of the comet. And up at the very top of the image, you can see kind of a little, circular spot where it's the brightest. That's the coma. So that's the gas and the dust that's around the rocky core of the comet.
Pretty cool. I'm inspired now. So what I'm going to do after we're done here, I'm going to try taking some more pictures of this, longer exposure, and I can stack them, and see if I can get. But I'm going to show you guys. Was this kind of going to be it in terms of the viewing tonight?
I was going to ask people if there was anything they saw they wanted to take a look at one more time.
Okay.
But yeah, then after that, I thought we would wrap things up.
I want to show people a picture though that I've been working on. That's pretty amazing. So you can have that discussion, and I'm going to go and pull this picture up.
Okay.
Well, I can also show my observatory. I can get a picture of that.
Oh yeah, that'd be fun.
But in being stuck in the house and all, I'm not stuck in the house, but we're all kind of quarantined, semi-quarantined these days. So I have made an arrangement to actually be able to get pictures from a remote telescope in South America, in Chile.
Oh, cool.
And so I'm starting to actually do some pictures and get some pictures. And I'm going to show you one that I worked on all day today. It's
cool.
called the Tarantula Nebula.
Oh, nice.
And the Tarantula Nebula, well, I'll show it to you in a second. Darn, I don't know that I don't have Photoshop in this damn program. Well, what can I do here? I need Photoshop to show this picture because I don't have it. I didn't make a JPEG of it yet. Oh, well. This is a TIFF, but it's not going to be a TIFF of the finished image. Yes, let's see. Let's see what this looks like. I'm not sure.
So while Mike is pulling that up, if
well, okay.
Oh, go ahead, Mike.
Well, this is it. Okay, yeah. Let me try. Okay, this isn't too bad. This is a narrowband version of it. I'll just show it to you. So this is a Tarantula Nebula. This is something like, I think it's 180,000 light years away. So this is not in the Milky Way. This is in the large I always have a problem. Magellanic, what they call a cloud, but it's actually another galaxy that's gravitationally bound to the Milky Way galaxy, and it's only visible in the southern sky. And so this is a view of it, and this is narrowband. This is taken with so the blue color is oxygen, and the pinkish color comes from the hydrogen. So that's and if I yeah, I wasn't thinking about showing this, and I didn't have let's see, there's an RGB.
Okay. That's a pretty amazing picture.
Yeah, it is. It's here's a RGB picture. Let's see what
And so, Mike, this is an Emission Nebula, right?
this is. An Emission Nebula. Yeah.
So similar
yeah.
to the Orion Nebula that we started with.
Right. It's huge though, because for it to be of this size in a this was taken with what's called the CDK-17, a 17-inch telescope, a remote in Chile. Let me show you this picture. The other picture was in some ways a little more interesting, but let me share this one.
And the Tarantula Nebula is known for the density of stars within it, right?
Yeah. Well, you can also see. You can see these also the clusters around. There's a star cluster over here. There's another open cluster here, and it's I can zoom in some. There's a lot of detail in this.
I feel like I was just reading something recently about how the density of stars in the Tarantula Nebula is greater than like any other known emission nebula.
Yeah, and it's I don't know how many light years it is across, but it's huge because the fact that is it fills the field of view at 180,000 light years away. That just tells you that it's a monster. And but that's a zoomed in view of the center part of it, and you can see this cluster of stars here. I have what I've done is this is a true color picture. It's not very saturated. It's but I put these two pictures that I just showed you, this one and the other one together, and it's pretty neat. Anyway, okay, telescope. Let me show you the observatory. Let's see. I assume I have. I say I'm going to do that. Let's see. Astronomy pictures. No, I want to go to astronomy. And I want to go to observatory. Let's see, there it is. And I want to go to observatory pictures. All right, and so here, I guess we'll just use this one. Okay, so now I just have to put it in share it. Okay, so here's the observatory with me in it. So that's the telescope we were just using, right here, right there. And that's my 6-inch telescope, which the 6-inch one was the one I took the Orion Nebula with that we saw earlier. And then there's a 12-inch telescope right here. So this is the Astro Haven Observatory. It's clamshell, so each side of it opens up. So that's the reason you can have 3 telescopes in one observatory. You don't have to have it right in the middle with a opening, you know, revolving as the telescope moves. You can totally open it up. And that's kind of, it's pretty much open up right now because we are looking all over the sky tonight. And in fact, if all goes well, this is the kind of observatory Samuel is planning on for Wyoming stargazing up on the summit of Snow King.
That's right, just bigger.
Yeah, and this telescope is the same brand of telescope we probably might be, but bigger.
Yeah, we're going for one twice as big.
Yeah, this is a 1/2 meter telescope, so you're looking at a 1 meter monster maybe.
Yeah. So Mike, it looks like the Virgo cluster is up now.
Okay.
So maybe we can end with a big elliptical galaxy, M87.
M87. Okay, so we'll go back up here. Let me do that. Let's see, M87.
And this will be the farthest thing we've looked at tonight, so it's kind of cool to end that way. 53.5 million light years away.
Okay. All right. Okay, well, this is on, the telescope does not have to flop to get to this, so that's nice. Let me see it.
Yeah, so about half of all known galaxies are spirals, and the other half are elliptical for the most part. There are also irregulars and other bizarre shaped galaxies, but spirals and ellipticals are the two largest groups. And ellipticals can get quite a bit bigger than spiral galaxies can. One of the theories of galaxy evolution is that spiral galaxies combine. Their spiral arms get torn apart and they end up as these giant elliptical galaxies, as Mike was talking about earlier with all the galaxies in our local group. So this is a huge cluster of galaxies that we're about to look into here. So we'll see one big galaxy and maybe several others as well.
Okay, so I'm gonna save this picture here of the comet. Okay, wait, actually, I don't have to get rid of it either. So, okay, we're gonna do go back to 4, and we'll do this. All right, so.
The other cool thing about this galaxy that we're checking out is that it has a huge black hole in the center of it, way bigger than the black hole that we have in the center of our galaxy. And it's also an active galaxy, active black hole rather. So this black hole was the one that actually just got photographed not too long ago. The first ever black hole we've ever actually taken a picture of in M87. So that big blob in the center there.
Yeah, so let me, yeah, let's see, screen stretch. Let's see. Yeah, it's what it is this is all part of the, I guess this is the galaxy right here.
That's the core of it, yeah.
The core of it. And if I do this, but there are other galaxies here.
Yeah, several of them.
That's another galaxy. This is another galaxy.
Yeah.
Yeah. And
yes, this is all part of the Virgo supercluster. There, I think over how many galaxies in this one, Mike?
I don't remember, but yeah, it's yeah. Ellipticals are not very interesting to look at because all you don't see structure. All you see is a glow. But yeah, there's at least 3 galaxies in this picture, probably more. That's probably another one there, here, here, and here.
And I think over 1,000 in the Virgo supercluster.
Yeah.
But yeah, that bright one in the center, that one is the host of the first ever black hole that was photographed just last year.
Cool.
Well, are there any last requests from anybody who's still with us? Any last thing
I think the best picture we had was M51. If anyone wants to go back and take one more look at that, we could.
I'd take another look at that.
Okay. All right. Yeah, that was our.
Got a thumbs up from JR.
Yeah. Yeah, it's just, fortunately, the mount's going to have to, it's just outside but I could, that's no problem.
Yeah.
It'll just take us,
All the way around.
it has to go around, yeah.
Yeah. Yeah, that's the nice thing about the 1 meter plane wave. It's an alt-az mount, and so don't have that problem with those.
You don't have to, it doesn't have to flop.
No, it just keeps swinging.
Plane wave now makes a software BISC makes a alt-az.
Oh, really?
Now. Yeah, they've gone into it too. It's not actually capable of doing my telescope, though. It's not quite as big enough.
Oh, okay.
My telescope weighs over 150 pounds. Yeah. But yeah, these the 1 meter doesn't come on. It comes only on a
alt-az, yeah.
Now you can see the telescope working its way around. There's M51 right there. And there's Hercules, where the M13 was.
Yeah. Yeah, another couple of weeks we'll be able to see the Ring Nebula.
Yeah.
You can see Lyra rising over there in the northeast.
Yeah, I have a nice picture of that. That's also another one that's a long. You can see the ring easily, but it turns out there's a lot of neat structure around the ring that is really faint. And okay, so we'll go back to the camera. And we'll take another picture, since I know it. We'll just go with it. Just this 30-second view.
On a really dark night like we have tonight with our 25-inch telescope, you can actually see the spiral arms of this galaxy just with the naked eye, look to the telescope without a camera. But you don't get to see the detail that we see tonight using Mike's camera.
Yeah. Yeah, 30-second exposure in a camera is way more. You're seeing way more than you can see with zoom this in on a. But there it is again. Yeah, I wish when I was taking pictures of this galaxy, I didn't have nights as good as this to take this kind of picture. What you need to get a lot of good pictures is a lot of nights that have this clear a sky. And it's not just the fact that the sky is clear, the scene is good, which means is that there's not a lot of blurring in the atmosphere. I can tell that by just looking at the detail that I can see here in this one exposure. And the fact that I can see that kind of detail tells me that the scene is really good. It's interesting the way I focus the telescope. You don't focus the telescope by looking through an eyepiece. You focus it by taking, it's an automatic program, and you take all pictures of the sky and it at different positions and for the focuser. And what it does, it analyzes 5 different pictures of all the stars in the sky, and then it figures out what the best focus was based on how to make the stars the smallest. And so that's the criteria. But one thing nice about focusing on the night sky is you have these nice little pinpricks called stars, and you just try to make a pinprick as small as you can. And but anyway, you don't have to do it with your visual eye. The software does it automatically, and so you get some really sharp pictures. But I can tell if I went back, and maybe I'll do it, went back and actually focused the telescope tonight, I bet you I get a really small star size.
Well, Mike, thank you so much.
All right.
That was a lot of fun. And everybody, thank you so much for joining us. Hope you enjoyed looking at all these images and learning a little bit about all these objects. And we're gonna keep doing this on several other clear Friday nights. We'll check out other objects. So come on back and join us again. And yeah, feel free to ask all the questions that you have, and we'll do our best to answer them for you. But yeah, again, thanks for joining us, and have a great evening.
Mike, thanks a lot. Sammy, thanks a lot.
You're welcome.
Terrific. Better than Netflix.
Okay.
Thank you all so much. It was
Way
wonderful.
better than Netflix.
Much better than Netflix.
Yes.
Oh, that's a great compliment.
No
Did you actually
comparison.
photograph? Were you recording this, Samuel?
Yeah, we've got it all recorded. I'll put it up on the website for folks to look at.
Cool.
We get hot chocolate next time?
Yeah, virtual hot chocolate and popcorn.
Okay.
I'm just happy my toes aren't frozen.
Well, I can share some scotch with you.
This was definitely the most comfortable night of stargazing I've ever had.
Yeah. Yeah.
Very cool.
Yeah, and as you say, I'm not out in the observatory either. I'm in a warm room at the moment, sitting here.
Yeah, I mean, that's the way to do it.
Yeah. Okay.
All right.
Good night.
Thanks again,
Right.
Mike. Have a great night.
Yeah. you
Thanks,
too.
Blake and Sam.
Yeah, thanks for being here, JR.
Bye, Sam.
Bye, see you later.